Okay, similar figures, okay? We have some definitions to go through, then we're gonna go through some examples of all these definitions. Similar figures are created when an object grows or shrinks by a scale factor. Similar figures are created when an object grows or shrinks by something called a scale factor. We'll discuss what a scale factor is in a second. A third one. Okay, so what we just got done in chapter 1 talking about was transformations that were rigid. There are transformations that are non-rigid as well, and we're going to talk about those in this chapter. So the transformations that were rigid were what three? Translation.
Rotation
and reflection. Translation, rotation, and reflection. Today we're going to talk about similar figures, and that is a non-rigid motion is what we're going to talk about today. Dilation, okay, something that is a dilation has the following characteristics. It's a process that grows or shrinks a figure by a scale factor. It has the same overall shape, but a different size. So on your test, when you took your test last, remember how there was like two triangles and said, are these congruent triangles? And one, a lot of you said yes, but the answer was no. Because one had like the length of like 7 on one side and one had like a length of 5 if you counted it. Okay, so that's considered a dilation, not congruent figures. So a dilation is a process that grows or shrinks a figure by a scale factor. It has the same overall shape, but a different size. The ratio of each pair of corresponding sides is the same. That means if I have a triangle, we're going to look at it in a minute. If I have two triangles, A, B, C, okay, and this one's like this, and it's C, D, E, F, okay, and they tell me that triangle ABC is similar, that sign stands for similar, to triangle DEF, then if this is 4 and this side length is 2, that ratio would be 4 to 2, okay? Which means that this here, let's say this is 8 and this is 4, that ratio is an 8 to 4 ratio, okay? And then let's say that this is 6 and this is 3. That ratio is a 6 to 3 ratio. All those ratios reduce down to the same thing. That's what it means by the ratios in each pair of corresponding sides is the same. Okay? When I put them in a ratio form, they'll reduce down to the same thing. And the fourth thing about a dilation is that the two shortest sides are corresponding, the two longest sides are corresponding, and so on and so forth of all the shape. Okay. Then you get to something called the scale factor. That is the ratio of the lengths of corresponding sides. So it's this part right here. It's the ratio of the lengths of the corresponding sides. Yeah. So if you have triangle, oops, if I could draw that would help. ABC, and it says it's similar to triangle DEF like we just did, I can set up proportions, okay, such as side AB, okay, the proportion would be AB over
Please
DE.
excuse this interruption. Austin, would you please call
Then
1001?
BC over EF. And CA over DE. Oops, I don't want to do that. Okay, so I set up proportions, just like I did here, but this time I used numbers instead of the letters. But you would be able to set up 3 different proportions comparing the side lengths that match up. And order matters, okay? Order matters. I have to follow the order of how it's listed. AB has to correspond with DE. BC has to correspond with EF. CA has to correspond with FD. Okay? We're gonna take a look at some pictures. We're gonna do one more slide of definitions, and we're gonna take a look at some pictures and show examples. How we doing with copying? Need more time? Any questions so far on any of those definitions or what those things mean? It's on the board. I need to know where Crystal is going.
Is this the start of chapter 2?
This is what,
Why is CA over DE?
oh, I'm sorry, it should say FD, shouldn't it? Sorry, you're right, it should be FD. Except for I can't write it as. Okay, FD. I don't know how to do that thing, probably. Okay, so that is what matters, the order matters. Let me call out Crystal. Hey, I'm missing Crystal Wilson. Okay, thanks. Bye. Okay, so then. I know. So then, we're gonna take a look at this. Similar triangles, okay? It tells us that triangle ABC is similar to DEF. Remember that this little squiggly thing like that means similar, okay? So triangle ABC is similar to DEF. And the reason I need to know that is because remember how this one, is it a double one, means congruent? Yes, and congruent and similar are different things. When triangles are congruent, that means their parts are equal. When they are similar, that means they're the same but different sizes, okay? So it says you have these two similar triangles. And it says, what is ED? They want to know what this is right here. How can I figure out what ED is?
Like what the length is?
Yeah, they want to know what is the length of ED. Anybody got a guess of how I could figure that out? What?
Well, BC is not congruent, but is similar to EF, so see how.
BC is similar to EF, so I can set up a ratio or proportion, okay? So I can say 7 over 3 is equal to what?
21 over X.
21 over X, good. 21 over X, okay? And then how would I solve this? What?
Cross.
Would you like, yeah, cross multiply, right? I'm gonna cross multiply like this, boom, boom. What is 3 times 21?
63.
63. And then I get 63 equals 7x. What is 63 divided by 7? 9. So x would equal 9. Okay? Now the way to check it is this. 9 over 21, does that reduce down to the same thing as 3 over 7? Is 9 over 21 3/7? Yes. So they now have the same ratios, and that's how I can figure it out. Because they are similar triangles, they should have the same ratios, so I can set up proportions and solve. Does that make sense? Okay, that was good. You guys figured that out on your own. Okay, we're gonna look at a couple other ones. That's just the first one. Then you have congruent angles. Identify congruent angles. Which angles are congruent? The triangles are similar. Okay, so here's the deal. When you have congruent triangles, that means all parts are congruent, the angles and the side lengths, okay? When you have similar triangles, the angles are still congruent, the sides are what's considered similar in a proportion. So, what angles are congruent in this? Give me an angle, wherever you want to start.
F,
Angle F. So what is angle F congruent to?
P,
To P? This one's tricky, isn't it?
because you have to.
You want to name it angle FED, right? Okay, so we're going to name this triangle FED. And we're going to name this triangle, what order does that triangle? You said F goes with
P, so P,
P. So PQR. You are correct. Okay, so that is that. So triangle FED is similar to triangle PQR. So angle F is congruent to angle P. What else? Angle what?
E is congruent to Q.
Angle E is congruent to angle Q. And what is my last one?
D,
D is congruent to R. Okay? So when you're dealing with similar triangles, the sides have similar lengths, as in the ratios are the same, but the angles still stay congruent. Okay? Similar triangles again. Let's see here. It says, what is AC if triangle ABC is similar to triangle DEF? How do I set that up? Okay, what L?
proportion.
A proportion. What proportion, Doug?
7.5
Okay, 7.5 over 3.75 because you know that EF corresponds with BC, okay? And it's set equal to what? 12 over X. Okay, you're gonna have to have a calculator out. We're gonna name that X for now. So I get 7.5X equals what? What is 12 times 3.75? 45. And what is 45 divided by 7.5?
6.
So X would equal 6. Now, compare. Is 6 over 12 the same as 3.75 over 7.5? Does it reduce down to the same? 6/12 is 1/2, right? So is 3.75 over 7.5 1/2? Yes. Okay. So that's how you can always check to see if you've done it right. Okay. Identifying congruent angles again. What angles are congruent, Carly? Give me an angle that's congruent. You're next. Give me one. A is congruent with what? With E, yes. Okay, what do you got?
B is congruent to
Okay, B and E, and that would leave
and C.
C and F. Okay, and that would leave angle C and F. That is congruent. Good. Okay. Last question, and then you can start your homework. An equilateral triangle is dilated by a scale factor of 0.75. The resulting triangle has shorter sides but angles of the same measure, has shorter sides and angles of smaller measure, has longer sides but angles of the same measure, or has longer sides and angles of greater measure. What do you think? What can we automatically eliminate? If triangles are similar, what does that mean?
Smaller or longer angles.
What'd you say?
They have smaller or larger
Not angles.
measure.
If two triangles are similar, their angles are still
The same.
the same. So I can eliminate this one here because it says angles of smaller measure and angles of greater measure I can eliminate, right? Okay, because I know their angles are still the same. Their sides are what in comparison? if I'm going by a scale factor of 0.75, do you think my triangle is getting larger or smaller? Smaller. So, which one would it be? Has shorter sides but angles of the same measure, or has longer sides?
A.
A. Okay, so you see how that process of elimination works there? So it's A. So if the smaller my number is, if my dilation factor is less than 1, it's getting smaller. If it's greater than 1, it's getting larger. Does that make sense? Common sense, can you figure that out? Okay, so now we are ready for homework.